All right, this is Convergence 2 Basic, yet another example. All right, so the goal here is we're going to find the interval of convergence for this Taylor series. All right, the idea with the interval of convergence, remember, is sometimes for some x's that you put in here, it will. So we're just looking at this thing, right? So for some x's that you put in here, if you, it will actually equal 2 over x, right? But for some x's that you put in here, it won't. And so we need to find that interval, the interval containing all of the numbers that when you put them in for x, it actually equals 2 over x. It converges to 2 over x. All right. So the first thing to see with this thing, let me rewrite it up here. We got 2 over x equals the sum 0 to infinity, -1 to the n over 2 to the n, x minus 2 to the n. First thing to see is that this is an alternating series. Okay, let's just write it like this right now because really we don't know that it equals 2 over x yet, because for some x's it does and for some it doesn't. That's why we got to find the interval of convergence to know when we can say that this actually equals 2 over x. For what x can we say that 2 over x is equal to that thing? Okay, so but anyway, this is an alternating series. Let's see how this works. Okay, when n equals 0, we get -1 to the 0, 2 to the 0, x minus 2 to the 0. Okay, now moving on to n equals 1, we've got -1 to the 1 over 2 to the 1, x minus 2 to the 1 plus -1 squared over 2 squared, x minus 2 squared, plus going on and on and on forever now. Okay. Now see what's happening here, right? When we have an even exponent, 0 is an even number, by the way. 0 is even. So whenever we have an even, right, we get, and this still works whether or not you believe me that 0 is even, right? Anything to the 0 power is 1, right? So this just becomes 1 over 1 times 1, otherwise known as 1, right? Because anything to 0 power is 1, so you have 1 over 1 times 1, that's just 1. Okay. Now, -1 to an odd power, in this case 1, we get -1 over 2, x minus 2, plus now -1 squared, that's a positive 1, just over 4, x minus 2 squared. And so you can see that it will be alternating positive and negative terms like that. So it's an alternating series. All right. Okay. Okay, now the last bullet point on the first page of the Notes and Learning Goals for this section, Convergence 2 Basic, it says an alternating series converges if the corresponding series with positive numbers converges. Okay, example, so they turn this one into a geometric series. Okay, same idea with the last bullet point, be able to find an interval of convergence by comparing a Taylor series to a geometric series. That's the last bullet point on the Notes and Learning Goals. So be able to find an interval of convergence by comparing a Taylor series to a geometric series. Okay, so what we're going to do is we're going to rewrite an, the formula for the terms, for the individual terms, as a geometric series. So remember that is something to the n. All right, so let's do that now. Okay, so we got -1 to the n over 2n times x minus 2 to the n. All right, so the first thing you can now I'm going to do all the steps, okay? I'm going to do all the steps. All right, so you got, put that over 1, right? Multiplying fractions. You got -1 to the n times x minus 2 to the n over 2 to the n times 1. Okay, this is over 2 to the n. All right, now to go from here to here, I'm going to use an exponent rule. You're probably used to seeing that rule. Let me use something else. Let's say x and y. We already got an x there. Now we already had an a. Let's do, let's say bc to the n is b to the n times c to the n. Because you're used to seeing it that way. Equals goes both directions, so we can go that way as well. Let me write it that way, since you're used to reading from left to right. Okay, so we're going to do that there. So this is like our b, that's like our c. All right, so we can write this as -1 times x minus 2 to the n. All right. Okay. Okay, now remember that negative x minus 2 is the same as 2 minus x. So you can go like that. Let's just see that real fast. You got -1 times x minus 2. That's distributive property. You got -1 times x. Let's see. Plus -1 times -2. That's -x plus 2 minus x. That's how I got that there. Okay. Okay, now we'll use another exponent rule. This one, I'm not sure how you've seen it. Maybe, let's do, b to the n over c to the n is b over c to the n. Okay, this is my b, that's my c this time. So this is 2 minus x over 2 to the n. So notice what we just found there. That was that this is equal to that, is equal to that, is equal to that, is equal to that. So that must be equal to that. Okay, so we've got -1 to the n over 2 to the n times x minus 2 to the n. These things are equal. All right, so put that in a box there. I know there's that little glare there, isn't there? Let me put it right here. Okay, we had 0 to infinity, -1 to the n over 2 to the n, x minus 2 to the n. Okay, because we found that this algebraically is exactly the same as that, we can rewrite this as to infinity 2 minus x over 2 to the n. Okay, this has the form of a geometric series, right? This number right here, this is my r. R equals 2 minus x over 2. Okay, remember that a geometric series converges when r is between -1 and 1. So we want to know for what x is r equal 2 minus x over 2 between -1 and 1. And so that's what we're going to find. All right, so -1 less than r less than 1. It's the same as saying -1, because our r is that thing. 2 minus x over 2 is less than 1. Multiply both sides by 2. Let's see, 2 times that, 2 times that, 2 times that. So we got -2 is less than 2 minus x is less than 2. Okay. Subtract 2 from both sides. And we get -4 is less than -x is less than 0. Okay, now we want to get rid of that negative, so we're going to divide by a negative, divide by a -1. Now remember, when you multiply or divide by a negative, you have to flip the sign, right? So this becomes 4x 0. All right, and that's kind of backwards, right? It doesn't seem, you're like, what does that mean, all right? So you can do it like this. Put the 0 there, put the 4 there, and then this is literally how I do it. This is literally how the mathematician does this. I say, where's the alligator mouth chomping, right? Okay, so like that. Let's see, and when you between the 0 and the x, the alligator is chomping the x, so it looks like that. Okay, so the answer to the problem, the interval of convergence is that. All right, think of this as an interval.